Welcome to the Technology and Energy panel of ISH Digital 2021. Today we've invited more experts from the heating sector. Today's topic, the digitalization of heating technology and networking within buildings. What role does networked heating technology play in a transforming energy system? What advantages does it offer to the user? That is what we want to talk about today. I'm delighted to welcome today's guests. That's Dieter Kehren, Head of the Department Energy Management Systems, EMS, and the Forum Smart Heating at the Federation of German Heating Industry, BDH. Welcome. Stefan Kluepfel, welcome. You're a member of the Department EMS. Hello. My first question is for Mr. Kehren. At the end of 2020, the BDH established the new department Energy Management Systems. What do energy management systems have to do with the heating industry? In recent years, we've increasingly seen heating systems being networked with other products such as photovoltaic systems, electric mobility, electric cars, battery storage, and others. And this is a trend that we've seen more and more, also in our member companies. And almost all of our member companies either offer energy management systems already or are currently working on them. Exactly, and we are also seeing energy management systems become more relevant in the heating sector when electrification takes place. And that's happening currently with heat pumps in Europe and in Germany in particular. By means of the BEG program, federal funding for efficient buildings, the Renewable Energy Sources Act, and new legislation such as the Building Energy Act. These energy management systems ensure that electrified heatings, such as heat pumps, are also optimally integrated into the network. How are these products actually networked digitally? Well, which products are we even talking about? Let's consider for a moment a new building subsidized according to KfW 40+. These days, that's a photovoltaic system set up on the customer's roof. There's a highly efficient heat pump in the basement, usually with battery storage in the basement too, which stores the photovoltaic energy for nighttime use. An intelligent measuring system is built into the customer's switchboard, optimized with an electric car charging station if the customer has such a car. These products are then networked so that the customer can generate price advantages, for example. So, if inexpensive photovoltaic electricity is available, an energy management system can control the heat pump and then supply it with 100% or almost 100% photovoltaic electricity in Energy Manager mode. Mr. Kehren, what role does the energy management system play in all this? The energy management system sort of monitors the energetic conditions of the building. It watches what the photovoltaic system is producing, the price of power from the grid, and how much the electric car or the heat pump are using. And these combined conditions are not only considered at the current point in time, that is now, but also as a prognosis for the future. And all the data that's collected and interpreted and evaluated is made available to all integrated individual products, such as the photovoltaic system, the heating, the car, so that the building as a whole can be regulated optimally. And what's optimal, that depends on what the customer wants. So whether it's more important to the customer to achieve maximum cost savings, or to contribute to the transformation of the energy sector, or to have security of supply or comfort. Do you have anything to add to that, Mr. Kluepfel? Yes, maybe. As Mr. Kehren has already said, the energy management system is in principle the central interface of the building, which connects the individual devices, collects data, saves data, locally on a local gateway or sometimes in a cloud, and this data is then processed in such a way that, depending on the customer's needs, they can operate the heat pump cost-effectively with excess photovoltaic power, for example. Or in the case of a modern power grid, as we now have here in Germany, variable electricity tariffs can be increasingly implemented. The heat pump or electric car are charged when a lot of solar or wind energy is available in the grid, when the energy costs are particularly low for the customer. Mr. Kehren, one of the main themes of ISH Digital is the European Green Deal. This has ambitious climate targets. In concrete terms, this means a 55% reduction in CO2 by 2030 compared to 1990. What role do energy networking and energy management systems play in terms of climate protection? The climate targets drive us towards the energy revolution, and the energy revolution changes our energy system. On the one hand, it's becoming more decentralized due to the large number of decentralized generation systems, photovoltaic systems and wind turbines, and on the other hand, the demand for electricity is increasing overall because we want to create electric mobility. We want to electrify transport as well as the heat generators. So we have high demand for electricity and we have decentralization. And if we wanted to solve that now by expanding, that is, grid expansion and expansion of generation plants, it would be a very costly exercise and very time-consuming. It would take a while. Energetic networking and the networking of buildings with energy management systems offer an alternative solution. At least a partial solution that allows us to avoid the cost of expansion. Also, with energetic networking and control using energy management systems, I can implement load management, for example. I can control the energy consumption of my heat pump so that it comes on when the grid isn't overloaded or when there's a lot of renewable energy available. Mr. Kluepfel, looking to the future, how will energetic networking in buildings develop? We assume energetic networking in the future will be focused not only on the building itself, but will also include the power grid outside the building, for example. I'm sure legislators will create incentives for customers to allow external market participants to control their consumption or their local energy generation system so that the power grid remains stable in the future. And we assume blockchain technology will provide a way for different energy generators, different energy consumers to engage in energy trading in a smaller local network. Then customers, for example those who have a photovoltaic system that will soon no longer qualify for funding from the Renewable Energy Sources Act, can benefit from the fact that their photovoltaic system can trade energy with a neighbor in their immediate vicinity who has a heat pump and wants to use the excess photovoltaic electricity.
Dem Nachbarn, der unmittelbarer Nähe ist, eben Energiehandel betreiben kann, weil der eine Wärmepumpe hat, die den überschüssigen PV-Strom gerne verwenden möchte.
How will your department at the BDH guide this development? We believe energetic networking and especially energy management systems will be key, not only in our sector, but for the energy revolution itself. And it's our view that we can best support our member companies by outlining where networking is required in the sector and what options the sector has for implementing networking and communicating that and serving as a point of contact for other industries as well as for the political sphere and the trades. That brings us to the end of what I hope has been an interesting program. We've talked about the fundamental changes that are happening in the energy world. Energy management systems in particular are making buildings an intelligent part of this new energy system, and heating technology plays a central role in this. I'd like to thank today's guests. Thank you, and thank you for your interest. Enjoy the rest of ISH Digital 2021.